And you know, it's funny whenever we're doing workshops like this, I try to think about what do I want people to walk out of the day remembering and knowing, because you can't remember everything. We can't turn you into preservation experts in one day. But you know, you think about what you learned this morning in terms of you know, what building codes to follow, what investigative documents are out there, structural performance. Oh yeah, this one I need. You learned about you know, environmental conditions, humidity and moisture, but I think one of the important things I want you to walk out of here today knowing is exactly what's happening this afternoon. I tell you one way of doing mortar joints, and Al says, well, that's not really how it works in practice, Mike. Here's what you really do. And I think the point is that there's a big move within the industry in the last few years to go back to you know, the relationship between the design professionals and the contractors on preservation projects. That relationship is changing. And what I mean by that is that it's almost impossible to think about everything that you need to going into a preservation project. You know, we're used to, as designers for new construction, preparing design drawings, preparing specifications to cover how we want our building to be built. You can't really do that with a lot of preservation projects. And so usually you'll find yourself interacting a lot more often with the contractor on your preservation projects. You need to be down there as they're doing the work, because the process of doing work, process of taking brick out for replacement or taking out mortar joints for repointing, they're going to uncover situations that you could never have dreamed of. And you can't physically address all the potential contingencies in your spec. So just be aware there's a different interaction between the design side and the implementation side on preservation projects. You need to be closely linked to the contractor on these types of projects. So I'm gonna do this. We're gonna do the same thing with lateral restraint anchors. I know this is one of Al's favorite topics. He's gonna love all of what he tells you about anchors. I'm gonna talk about the different methods that are available to you for installing lateral restraint anchors, and probably go for about 20 minutes, and then we'll take our afternoon break. So here we are talking about lateral restraint anchors. Well, what exactly is a lateral restraint anchor? By definition, really, if you looked in the building code, these pieces of metal that are inside some of our masonry walls would be called a veneer anchor, or just simply a wall anchor. And they are metal elements that span, here's a section of a wall, they span between the veneer, the facing of your masonry wall, and whatever the backup system is. I've shown steel stud here, or it could be wood stud, or concrete block, or it could just simply be additional withes of masonry. And those anchors perform a very important, fulfill a very important purpose within your wall. And if you want, you can take notes. I'll pass out another little handout. You can pass these around and take notes as we go through here. But these lateral restraint anchors fulfill this important role of transferring lateral loads from the veneer to the backup system. And that could be lateral loads from wind or seismic. Very, very important that those are inside our wall to tie things together. And they typically take the form of little bits of metal. They could be wire ties, as we see up here in the upper left. And here's a nice little representation of many different types of metal anchors that you can find in historic masonry construction. They can be straps. I've seen little wire mesh, you know, but even back in the 1800s, almost like a hardware cloth that masons used to tie the face brick to the backing brick. In more modern construction, you'll see joint reinforcement, right? Joint steel, Durawall. This is our small diameter wires that are connected. This is a tri-rod joint reinforcement, one rod in the brick veneer, two rods in the concrete block backup system. Now, why would you ever want to install a retrofit anchor? That's our topic really for the next little bit, retrofit anchors. Very common really to install retrofit anchors as part of a preservation project. Why would you want to do that? Well, sometimes it's due to the original construction. Maybe the anchors weren't put in right in the first place. Maybe they were just installed mistakenly at the wrong locations. And here's Robert. Robert used to work for me, he's scanning a wall to detect the metal elements that are inside. And a lot of times I'll just mark with chalk on that wall surface or a piece of masking tape every time the scanner tells me, oh, there's a tie. And in reports, we'll show these as little crosshatches for the client. And this building, I'm going to show a couple photos of this building. This building had some issues, and I couldn't find any rhyme or reason really to how they put in the veneer ties. They were at a regular spacing some areas, other areas they were not at the right spacing. And the fellow this morning said, okay, you can scan for ties and tell me I've got metal in there, but how would I know it's installed correctly? And that's exactly what happened here. I was getting just some strange readings at these areas. I didn't mark them in black, but in purple, because I wasn't too sure what was going on. We went in with the borescope then and looked at the ties. This is a borescope application, actually looking at a corrosion of a metal anchor in a stone construction. But for this wall on the upper right, I went in and looked at the metal ties with a borescope and found out the metal was in the wall. The contractor just didn't install the anchor through the facing Y. They just turned down the anchor in the cavity, so it wasn't engaged in the mortar joint. Other areas we found, okay, here's a whole series of veneer ties. They did it great. The inspector must have showed up right when they were building this part of the wall. But other areas, this whole area was scanned, no veneer ties. So this is a representation or example of one condition where you might have to install retrofit anchors. Poor construction, poor installation, these poor little corrugated veneer ties that go in a lot of modern masonry. There are some limitations in the code now about where we can use these, what size corrugated ties we need. And I think the most common error we see with installation of these corrugated veneer anchors is, well, there's twofold. One is installing the anchors with a galvanized roofing nail, just intercepting the sheathing itself, just into the plywood or the oriented strand board sheathing. These anchors are taking a fairly significant force. When you can pull an anchor out of the sheathing with your own hand, that's not enough resistance to force. Correct application of corrugated anchors would be nailing these anchors into the studs themselves. And you know, you don't have to open up walls to look at anchors. You can, again, use a fiber optic borescope, drill a small diameter hole into a mortar joint, and what we're looking at here's your corrugated anchor turning up. Here's your nail head. Just wind action over the years that since this home was built was enough to dislodge this tie and actually start pulling the nail right out of the sheathing. Why else would you want to install retrofit anchors? Well, this is a pretty interesting building that we worked on, and the architect and contractor called us out and said, Mike, we've got this big bulge in this wall. We're not too sure what caused it. What do we do here? And you can't see the bulge in this wall, but you can see something very important. If you're observant and you know about historic construction, you're going to not see a very important element in this face brick. And that are header courses. Alan talked about header courses and how brick turned into the wall are used to tie facing brick to the backup brick. You know, before metal anchors became commonly used, and it's great because I showed up on site and for whatever reason they didn't think about the concept of header courses. And I saw right off the bat, well, there's no headers. That's telling me something different is going on here. And you can look really bright on job sites if you go out there and say, well, there's no header courses. That means maybe there's some metal ties, or maybe they used this blind header arrangement. And it was very commonly used in our area, say from 1900 through maybe 1910, 1915. This concept of using blind headers, and these are diagonally placed header brick that don't come out to the face of the wall. So if you walk up to a building, an historic building, and you don't see header courses, that is brick that are turned in a row-lock orientation so that you can see the end of the brick at regular intervals up the height of your wall, it tells you either metal ties were used or this blind header arrangement was used. Is this a good or bad system? Well, it's good from an appearance standpoint. You have an unbroken running bond at the face of the wall, but it's bad because these diagonal headers took a lot of labor to put in. Think about it. For every diagonal header, the mason had to cut 4 brick.
Were those stacked or maybe at different height?
They would be put in just like normal header courses, and sometimes you'll see it like we see on the right, just a whole series of diagonal headers, one after another, every 5, 6, 7 courses up the height of the wall. Other times, you'll see a header, a diagonal header here, maybe one down the wall a little ways. And, it's an important concept because since these are so expensive to put in, or they were expensive, the mason having to cut all these brick to put in these diagonal headers, guess what? They cheated. They cheated a lot. And if the inspector or the architect wasn't on site, it's not uncommon to go 5, 10 feet between header courses. And these little diagonal headers, every 10 feet, that's not enough to tie things together and keep that face brick on. And so a lot of times, it just seems to be epidemic in our area anyways. These buildings are about 100 years old now, and just gobs and gobs of them are getting repaired with retrofit anchors. More modern construction, maybe I think metal veneer ties were common starting in say, about 1915. They replaced the diagonal header concept. And anchor corrosion is another very common reason why retrofit anchors are put in. We've been working on the UN building in New York since about 2008. We have a very small role in a humongous project. Our role is to look at the stone connections, the stone anchorage, and the condition of stone facing throughout the complex. And looking inside the wall and actually pulling stones out to conduct probes, we found anchors in any one of a wide range of conditions, from perfect galvanized, look like they were put in yesterday, to little crumbled bits of iron oxide powder, really. And so metal corrosion and corrosion of anchors and ties within walls is very common. And the same thing happens really with galvanized anchors. And again, this veneer system was tied together not with individual spot anchors, but with that tri-rod joint reinforcement system, where we had one small rod embedded in the mortar joints at the face of the wall and 2 rods in the concrete block backup. And this is considered an historic building. It was built right after World War II. I think the construction went into 1950 or so. And if you look close on this elevation, you can see the ties had corroded to the point where there was movement in the building. We've got some really significant bulges. Actually, this veneer was bulged out about 3 inches. I have no idea how it was standing. And we were really worried because this is a university campus, a college campus in Ohio. Luckily, this building was shut down for renovations, but I could not give the contractor a good approach for tearing down this section of wall and rebuilding it. I couldn't tell him how to get those brick out without them falling in his lap. And luckily, we procrastinated long enough that we didn't have to worry about it. And the whole section of wall ended up in the parking area at the back of the building. These things can happen. Instability due to corroded anchors, good reason for installing retrofit anchors. Looking at wall movement, using a simple plumb bob dropped from above the roof line, or if you want to get fancy, you can use a laser level, and measuring plumb. And this is not a plumb reading from this building, but you just don't get to see things like that very often. You can really see the bulge there. So very importantly, if you do plumb measurements and vertical plumb lines, make sure you take a plumb line on the front face of the wall and the back face of the wall. It'll tell you if the wall's moving as a unit or if one layer is pulling off of the other. And that's exactly what happened here. On the front face of the wall, we were measuring a bulge outwards, and then the wall started leaning back in about 1 inch. Back side of the wall, we didn't see that same outward lean, just was leaning inward. So this 3/4 inch separation there between that we measured, difference interior to exterior, is actually one layer separating from the other. And I don't care what kind of tie you had originally, full header courses, blind headers, metal ties, you can't get 3/4 inch differential movement from one layer of the wall to the next without telling you that connection has failed. So, good reason to put in retrofit anchors. There are different ways to design retrofit anchors. Let's see, the folks this morning talked about engineering design using the MSJC code. And I think one of the common places I'll turn for advice on how often do I put a retrofit anchor is simply the veneer section of the current building code. They have some nice empirical relationships saying, okay, if I put in an anchor, I need one for every 3.5 square feet of wall area, vertical, horizontal spacing, max. This is a pretty good starting point. But remember, one of our tenets of preservation philosophy is to minimize our interventions. So normally, when we're looking at historic construction, we'll go a little bit beyond the empirical relationships and actually analyze how much each anchor can resist in terms of load, so that I can space those retrofit anchors out as wide as possible. And so, whereas the code tells us empirically, without doing any calculations, you can put a tie every 32 inches on center horizontally, we'll very often go up to, say, 4 feet or more on center. You can design using the engineering requirements, anchor bolt, allowable stress design, strength design method. Very important question, though, is that, one of the problems with looking at this MSJC code and applying it to historic buildings is that this code was not designed with historic construction in mind, and we found that some of the design relationships in that code really don't apply well to some of our retrofit situations, and particularly related to anchor design. The difference in this case, and maybe it's getting off on a tangent, but I think it's kind of interesting, the code is talking about designing anchors that are installed during construction, say a grouted anchor. And if you look at the tension failure of that anchor, you develop a shear cone from the base of the anchor out to the surface of the wall. What we found with retrofit anchors, and this is an epoxy anchor, when you pull on that, you don't get the failure cone starting from the base of the anchor, but you get a little bit of pullout and bond failure for about the first couple inch or more, and then you get a failure cone developing. And I bring that up because, the types of failure modes that you're designing for, you can have fracture of steel, you can have the anchor pulling out due to bond failure, or this kind of combined breakout mode where you get a bond failure and development of a shear cone. You're designing, say, your anchor if you need your anchor to resist shear loads, you're designing for either steel fracture, crushing of the masonry in front of the anchor, pry out, or again, development of a shear cone towards the free edge of the masonry. So designing anchors, you can follow the MSJC code. If you're interested in some more information on anchor design, let me know. We've got some nice publications that I think outline the process that I think makes more sense for retrofit anchors in masonry. Now, calculations are great, but the reality is, since there are so many different types of brickwork and different types of construction and workmanship out there, most of the time, to qualify retrofit anchors and lateral restraint ties, some type of load testing will be required. And there's a mechanism in place in the building code that gives us guidance there. Code says we've got to test at least 5 anchors. They give us some factors of safety we can apply depending on the design approach we're using. That's covered in chapter 2.1.4.2 or chapter 3 of the MSJC, depending on your design approach. Test your anchor bolts and tension and shear. So let's talk about the different types of lateral restraint anchors. There are many different types: dry fix, grouted, epoxy. But before you even think about putting in an anchor, you've got to think about, how am I going to install it? What is the backup system? If it's a concrete block backup or a brick backup or concrete backup, you can put your ties in anywhere, right? Because you're going to hit solid material. If you've got a wood stud or a steel stud backup system, you've got to find those studs first. In this case, we're using infrared thermography, just a thermal scan. Gordon talked about infrared this morning. But you can use the same technology from the inside of a building and actually almost see directly through the drywall. Here we're seeing a steel stud system. See the drywall, the space in between. You can actually pick out each connector, each screw in the steel stud. If you know the exact locations of these studs, then you can transfer those locations to the exterior, and that really guides your layout of your retrofit anchors. Helifix pins, and I'm not going to pass these around, but maybe I've got examples of all of these different anchor systems. I'll just lay them out here on the stage right after we're finished in the next few minutes. We'll take a break, and you can come and take a look at these different types of pin systems. Dry fix Helifix pins are kind of interesting. They go in really quick and easy. They're like almost like a self-tapping screw. Stainless steel. Drill a pilot hole, okay, with a rotary drill, and then use a special attachment on a hammer drill to drive these pins in, and they kind of cut their own threads on the way in. They're not a real high capacity anchor, but for resisting wind and seismic loads, you only need a few 100 pounds of pull-out capacity for that purpose. And you can get that. You get, I think, in a good installation, we've done pull-out tests, and you can get 300 to 400 pounds pull-out capacity in good, competent masonry. The nice thing about these pins is they go in through quarter-inch diameter holes. There's a building at University of Missouri, and if you look close, you can see some little holes at the intersection of the bed and head joints where these pins were installed. And but otherwise, it's almost an invisible fix. The setting tool countersinks these pins below the surface. You point up the little quarter-inch hole with mortar, and you walk away, and you really can't tell that some very important repairs were done on this building. Expansion anchors also available. They're really kind of expensive. They have their place. There are some situations when you might want to use an expansion anchor. They work really well for getting you greater pull-out loads, particularly if you have a solid backup like concrete. Anybody looked inside an old brick wall? Not always solid, is it? I mean, there could be voids, there could be open mortar joints, there could be rubble infill in an old stone wall. Expansion anchors have to have something to expand against. So there aren't too many situations where I'll use these expansion anchors in historic masonry. I think there's some better options. One of those better options is an epoxy anchor. I normally stay away from epoxies with historic construction, but they have their place, particularly if you need some high pull-out capacities. If you're putting in, say, a structural connection, a structural fixing for a load-bearing point or a clip angle, something like that. Now, what's interesting about this epoxy anchor system is that, of course, there's a metal bit, a threaded rod that is the heart of the anchor, but around that rod, it's surrounded with a mesh screen. And the purpose of that mesh screen is to deal with the voids that you might find inside an old historic brick wall. So that screen goes in the hole. Actually, when you fill that screen with epoxy, some of the material squeezes out of the screen and grabs onto the brick around there. Without that screen tube, if you've got a void in the wall, all the epoxy is just going to run it down in your void, and your anchor won't have any capacity at all. So the screen works to keep most of that material around the anchor. You put the screen in, fill it full of epoxy, or a certain number of pulls on the trigger there, and when you put in and when you install your threaded rod, then some of that epoxy squeezes out and grabs onto the surrounding brickwork, and you've got a real nice structural fix, and you can get, not 200 or 300 pounds of pull-out, but several thousand pounds of capacity out of this type of anchor system. I think we've had better luck with grouted anchors, and a similar concept with grouted anchors. A fabric sock is actually used around the anchor to contain most of the grout that goes in, similar to the screen tube system we just saw with epoxy anchors. And there are all sorts of different configurations the manufacturers make. You can have a sock on each withe. You can have a continuous sock running through, say, a hollow or a void space within the wall. And here's one way that these get installed. You drill a hole typically that will not be into a mortar joint. To get better capacity, that hole will be drilled through a brick. That's not acceptable on some preservation projects, but sometimes it is, particularly if you have a compelling structural reason for installing that anchor. You'll have to come up with a patching approach for using a repair mortar for patching that hole at the face of the wall. But drill a hole, you clean that hole out, you pre-wet things, you pre-wet the sock itself, install that into the hole, and then hook up a small pressure pot or a small injection machine to inject a cement-based grout. Most of that grout stays within the sock. Some of it leaks out and bonds into the surrounding brickwork, surrounding stone, what have you. Really effective grouted anchor approach. Yeah, don't let this happen to your building. So It does happen. And actually, this again was a wall with diagonal headers, the blind headers. You can kind of see them poking through. Here's a course, here's a course. Not too bad, but probably about 10 courses apart. Not enough, apparently. So it's time for a break. Thanks for your time. I appreciate it. What's our schedule after this? Al's going to come up. He's going to get ready during break. Let's say it's 2:40. Let's take 15 minutes. We'll see you back here at 5 to 3. Yeah. All right. Thanks. Appreciate it.